Hey everybody, this is Larry. This is day 16 of the Leetcode Daily Challenge in March. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's prompt. Oh yes, wish first to AC, get that 10 lead coins. Yeah, alright, let's get started. I hope everyone's having a good week. It's really cold here in New York this week, so I'm just like, I just came from the outside, so I'm a little bit if I'm sniffling too much, my apologies. Okay, so today's problem is 106, construct binary tree from Inorder and Postorder. I think this is a very, I wouldn't say common, but it is a very well-known problem just because it is one of those things that they teach you in a textbook or something like this, and we'll kind of think about how to do it together. Some of the notes are unique because otherwise it's just, it's a little bit more awkward. Okay, so I think the biggest thing that this teaches is this idea of an invariant, right? Meaning that, you try to keep state and kind of figure out what things mean in each, as you kind of make, as you kind of make changes, you try to figure out what stays the same. That's what an invariant is, in fancier word, but that's basically, and based on that assumption, you can create a loop invariant or a recursion invariant or something like this, where you can, solve the problem. So this one, the invariant, the idea is that the in order is left current post, left current right, and post order is left right current, right? So maybe we could type that up. Hang on. In order is left root. I guess that's terrible. Parent maybe. And then post order is left right and then parent, right? So then here you can see that the left node, the current left node, right, is going to be the you can see that the left node is going to be the common pieces between these two things, and then you can kind of maybe play around with that, right? Okay. And then basically, yeah. I think the other thing that you can do is also, depending on how you want to do it. I mean, I think maybe that's sufficient, but maybe it's not the easiest way. I'm not actually quite sure. I haven't done this in a while, but in this case, the post order, the parent is always going to be the last node, just the way that it is, structured. So then now you can use this to figure out in the in order which one is left and which one is right. I think maybe that's a little bit easier of an invariant, or a condition that we can figure out. So let's do it, right? So how do I want to construct this, right? So maybe we have something like construct left right, and this is going to be left right on the in order. So this is going to be inclusive, just to be clear. Is that the inclusive one? And let me just write inclusive on the in order, right? And that's the thing that we parse, right? And in the meanwhile, on the post order, we can actually use a stack, an explicit stack in this case, perhaps, to kind of iteratively, maybe not, iteratively might not be quite the right word, but just like, get the parent or the root node or the current node every time, right? So maybe we can do something like this. Let's just say post stack is equal to, I mean, I know that in Python they're the same, but I just kind of want to make it explicit, I suppose, because I don't want to manipulate the input in that way. Okay, so then now, and then so that one thing that you can do now is that, okay, I mean, I'm going to there is an optimization to be made here. I'm going to make it a little bit later. So definitely, if you already know what I want to do, then bear with me. But basically now we can say that the current node is equal to postStack.pop, meaning the last item. You know, we're trying to get this P right here, right? And then now we're trying to find in order from left to right, we're trying to find in here the index that contains the current thing, right? So, I mean, I'm going to write pseudocode a little bit, so, you know, don't worry for now. Middle, yeah, something like that. Maybe just index, say. Is equal to this dot find, I think it's actually called dot index, but this is a little bit off just because, I mean, I guess this kind of works actually. Of current plus left or something like this, right? Something like that, give or take. Maybe I needed this to be inclusive, so it's right plus 1, but should be okay. And then now, a current node is equal to a tree node of the value of, well, current, right? Because I guess that's what you get on a stack. And then node.left is equal to construct from left to the index -1. And then node.right is equal to construct index +1 to the right. And then we return node. We have to definitely change some base case here, meaning that if left is greater than right, we return none. And I think this is maybe okay. I don't know that, I mean, there may be some like weird edge, not weird, but just Larry weird edge cases with respect to popping, but I think the structure of the code seems about what I want it to be. So then now we just return construct 0 and then length of in order -1 because it's inclusive. And then let's just give it a spin real quick. 20 is not in the list. Dun dun dun. Let's kind of take a look at that then. Left, right, in order, left, right? Okay, so maybe I mean, it's very possible that I messed up. So first of all, it takes the 3, it looks at the 9, and then it, Okay, so I am a little bit off here because it tries to do the, I didn't really pay attention to the construction timing. Because, so yeah, so that's my fault. But yeah, so then post order, what does that mean, right? That means that recursively, if we want to call the parent, we have to do the right side first, because that's the last item is going to be the right size item first. I don't know if this is sufficient to fix it, but let's kind of at least give it a spin. And that looks okay, right? Yeah, I mean, the test cases are not so strong that I am confident, but that looks okay. And in theory, you can submit it now, but what is the complexity here, right? Well, it's going to take time limited, exceeded, because, well, we printed stuff, but also because this is O of n. And because we do a lot of construction, if you assume a balanced tree, then it'll be n log n, but you cannot assume that. So that could be, in theory, like a linked list, and this could be n square if this is like the last item every time or something like this, right? So the next thing to do is make this operate in O of 1 time. And that's where all the uniqueness, I mean, well, it's also part of that comes in. And the thing is to just have a lookup, right? So maybe in order lookup. Terrible, whatever. But. And then now for index x in enumerate in order. Oh, jeez. Oh. Excuse me, friends. Oh, man. Man, I don't know what's going on. Oh, sorry, friends. Hope it wasn't too loud. Alright. I think I have 80% of that out of the system, so maybe there's one more. But anyway, yeah, this just looks up the index, and then now we can do this in a O of 1 way, right? Current. And that's pretty much it. Let's give it a spin again. Maybe I should have kept track of the timer, but let's give it a submit. Should I? Yeah, I mean, okay. I was just checking to see whether there's like a 0 case, like 0 length case or something like that. All the other stuff I think doesn't matter unless I mean, only thing that could happen is that I time out, but it looks okay. So yeah, 1080. So what's the complexity here, right? Well, obviously it's going to be linear space. We use a lot of that space. And well, this one doesn't have to be honest, because you can replace this with an index that goes through Postorder, because all we do is kind of look up, you know, an index lookup, right? So that didn't have to be. I think this lookup needs to happen. Yeah, I mean, maybe you could do something a little bit smarter, but not really. I don't think so. So yeah, linear time, linear space, linear time, because this will take all the operations. Excuse me. All the operations here are all of 1. So, and we look at each node once, and they're end nodes, so that's gonna be linear time, linear space. Yeah, that's what I have for this one. Let me. I'm curious what I got wrong previously. Oh yeah, I did do the index last time. Did it not tell you what the wrong answer is anymore? Or like, I mean, I know that is wrong answer, but don't they like give you a test case or something? I feel like they used to do that. I don't know. Oh, I guess it seems like here I don't pop one off. But now this time I think I wrote it more generically, so I didn't have to. Okay, cool. Yeah, that's all I have for this one. Let me know what you think, and yeah, stay good, stay healthy, to good mental health. I'll see you later and take care. Bye bye.